Chapter 10.2 is now going to be taking 10.1 a bit further. We're still going to be basically doing the same thing that we did in 10.1, except for I actually think 10.2 is a little bit easier because you actually have direction with where you're going with rewriting and manipulating one expression. So 10.2 is verifying trigonometric identities, and what's going to be happening is you're going to get these equations, this one expression set equal to the other, and what you have to do is maintain the goal that you want to take one expression and show that through steps of manipulation and rewriting you can make it match the other. So we're only going to be doing one at a time. It's not that you're solving for anything, you're just rewriting one side until it matches the other. Alright, so here are some guidelines for verifying trigonometric identities. I am going to bring back up the 10.1 things that we went over. I'm going to first be giving you what are the different manipulation methods that you can do, and then also what are those trig identity that we were using. So I am going to be reviewing those, but these are some new things that you might want to write down. So when you are verifying trig identities, you work with one side of the equation at a time. So don't be, for example, adding 2 to one side and then adding 2 to the other. Okay, that's not what we're doing. It's not like the equations where when you're solving for something, what you do to one side you have to do the other. It's not like that. We're not solving equations, we're just reworking one of the expressions until it looks like the other. So you're just going to be rewriting one side so that it's equivalent, and rewriting some more. And once again, you only want to do one side at a time. So you're going to use those manipulation methods from 10.1 to rewrite the chosen side. So you're going to choose one to work with. And then if you reach a dead end or things are going the wrong way, start over using different manipulations and identities. Because remember, for example, when we had, this is just one example of where we might go one way, but then it turns out that we want something completely different. For example, if we had 1 minus sine squared of x or something like that, maybe you were trying to rewrite it and you chose to use the Pythagorean identity, so you went ahead and used that this is equal to cosine squared of x. But as you're working down the line some more, it's turning out that this is not where you wanted to head. So I'm going to go ahead and cross this out. There's other things that 1 minus sine squared of x is equal to. For example, it's that factoring method. So we could have written something like this. Okay, because this is a red flag. Oops, that was Aldo. This is a red flag for Pythagorean identities when you have a 1 and then a trig function squared. But also, if you have a perfect square minus perfect square, that's also another red flag that you may need factoring, and it's that special case of factoring. So here is just a quick review of what we have in 10.1 if you need to look back at the 10.1 video. But here is just the list of all of those different identities, and when we were working with these in class, a lot of you had these memorized. So this is good. So you are going to need to use those in your process of rewriting. And then of course there's these methods of manipulation which we went over in the 10.1 video as well. Alright, so this section, like I said, is kind of easy. I'm just going to start going, or not easy, but I mean, it's a lot of what we've seen before. So we're going to start reworking, or just working through examples. Alright, so I'm going to start with number 5. And like I said, I kind of know what I'm doing with these, but believe me, when I was working out your homework problems, there were a lot of times that I did go the wrong direction and I had to start over. So I think I didn't even erase my work, so you can see that when in the binder that I have of all the homework problems reworked. So I'm going to go ahead and start doing this problem. Both sides actually are kind of complicated, so I'm actually going to just choose this side and see what I can do with that. Okay, so I'm going to, this one's kind of strange, but I'm going to just look at this cosine squared of b. And I do know that I want 2 sine squareds of b over here. I can see that. So this is where verifying trig identities may be easier because you have a sense of the direction you want to take. So if I could just rewrite cosine squared of b, I want to get this out. I kind of want to keep that one in. So I'm going to use the Pythagorean identity on this. That Pythagorean identity, once again, is cosine squared of, this is actually beta, not b, plus sine squared of beta is equal to 1. So I'm going to try to match that cosine that's in my problem, so I'm going to solve for it. So I'm going to subtract sine squared of beta from both sides. And what I've just determined is that cosine squared, of beta is equal to 1 minus sine squared of beta. So this is what I'm going to be putting in for that cosine squared of beta, sorry. So out with this, in with the 1 minus squared of beta. Okay, so that's this right there. That's completely using the Pythagorean identity. And then so now I'm going to subtract sine squared of beta. So I'm going to write off to the side. That was the Pythagorean identity. And I would like to see you write down the identities that you're using, because that way you can look over your work and see which ones you're using most. So now I'm going to go ahead and I'm just going to simplify this. These are like terms exactly. So I'm just going to say that I have 1 minus 2 sine squareds of beta, and there we have it. I'm going to take that and point it up there because what I've just done by simplifying is shown that this side, through rewriting it using the Pythagorean identity and then rewriting it using simplification, I've matched it to the other side. Okay, so that's what you're doing. I'm going to skip that one. We'll go in order. I also wanted to do number 19 with you. So this is where I'm headed. This is what I have. Once again, they're both kind of complicated, except for I see this plus here, and there's no plus over here. So what I can kind of see myself doing is that I'm going to want to condense this. So maybe I'm going to write these as fractions of cosine and sine, and then I'm going to condense them into one fraction. Because I do want to get rid of this plus. So that's what I'm going to attempt to do. So again, I am going to work with this left side here. That may not always be the case, but I'm going to go ahead and rewrite cotangent of alpha now in terms of cosine and sine, and cotangent is the reciprocal of tangent, so it's not opposite over adjacent, and remember opposite is the vertical motion, which is sine. So tangent is sine over cosine. Cotangent is going to be cosine of alpha over sine of alpha plus, and then tangent is going to be sine of alpha over cosine of alpha. So once again, I'm going to leave this alone. I'm just going to rewrite this until I match it, and that right there was the quotient rule, or quotient identity, I should say. Okay, so now this is that part where I'm going to condense fractions, and that's one of your methods of manipulation. So I'm going to go ahead and combine or combine, but don't forget you need a common denominator, I'm going to write. So I'm going to go ahead and say I need to multiply cosine to top and bottom over here. So cosine of alpha. Over here I need to multiply top and bottom by sine of alpha so that I can get sine going on this side. So when I do that, I'm going to get cosine of alpha times cosine of alpha is cosine squared of alpha, plus here it's going to be sine squared of alpha. And this is all over that common denominator. Now don't forget, you don't have to add those or anything. It's just like 1/2 plus 1/2 is 1 plus 1 over, and then 2, because that was common denominator. So we have cosine of alpha, sine of alpha. Okay, so now I'm at the point where I can kind of see, if only this top was equal to 1, because here I have cosecant of alpha, secant of alpha, which are the reciprocal functions. And right there, this is a red flag, huge red flag, actually. This is a Pythagorean identity. So I'm going to use that Pythagorean identity. Okay, and I'm going to write this as 1 over cosine of alpha, sine of alpha. Okay, And what I can hope you're seeing here is now I'm going to expand these two fractions, being that it is multiplication going on. I can just go ahead and write this as 1 over cosine of alpha times 1 over sine of alpha. Just go back and check your work. Does this actually line up? Did I break this right? And yeah, if I multiply these two fractions, when you multiply fractions, you multiply straight across the tops. Yes, I get my 1. Multiply straight across the bottoms. Yes, I get that. So this right here is just expanding fractions is what I would say. Okay, and then finally, the reciprocal identities that we have. Recip identities that I have. This is going to become secant of alpha times cosecant of alpha. And once again, it's kind of confusing because sine, the reciprocal of sine, goes with the c of the reciprocal identities, and then cosine goes with the s, but it's backwards of what you would think. And so there we have it. You can go ahead and flip those around if you want because multiplication is commutative. But, you can kind of see it. What we did was we just matched it there. And all of these, once again, can go back to, I'll show you them, these methods of manipulation that we had. Okay, so once again, like expanding fractions was here. Actually, this one is an example that's very parallel to what we just did. Combining fractions is right there. That's one of those manipulations. Oh, look, sum and equal expressions found on the identities card. Cosine squared of x plus sine squared of x is equal to 1. We used the Pythagorean identity there in that example as well. And then, of course, we had all of these. We used the quotient identities, and we also used the Pythagorean one. Obviously, this one's big, so big. Okay, huge. Use it a lot. Okay, 27. All right, one last one, and then I'm going to call it quits. But here, once again, so simple over here. You can see why we want to start out with the more complicated one. It makes no sense to start with the more simplified one and make it more complicated. So we're just going to try to be reworking this one, the one with a lot of parts to it, reworking all the parts until we try to bring it together. So I know I'm probably going to try to condense these fractions. So once again, I'm going to try to get a common denominator. So I'm going to need cosecant of x plus 1. And then over here, I'm going to do sine, whoops, that's an I, of x plus 1. But then, sorry, I should have done this before. If whatever you do to top, you got to do to the bottom. Okay. So here, what's going to be going on? I have cosecant of x plus 1 on the top, plus, and then over here I have sine of x plus 1 on the top. And then on the bottom, we're going to actually have to FOIL this out. So cosecant of x times sine, I am just going to write this all out. Sine of x, so fronts, outsides, insides, and lasts. So right now, that was just me combining fractions, adding them to be precise. Combining, once again, I needed a common denominator, common den. Okay, so now I'm going to go ahead and look at this right here. What I have is cosecant and times sine of x. What I do hope you see is that's kind of a red flag too. Cosecant times a sine. They are reciprocal functions, so reciprocals when multiplied are just going to equal 1. So cosecant of x plus, I'm going to kind of write over myself. Actually, I'm sorry. No, never mind, sorry. I'm just going to write it all out. Okay, so this is going to be 1 over sine of x times sine of x plus cosecant of x plus sine of x plus 1. Okay, that right there was the reciprocal, recip. Okay, so I'm just going to go ahead and simplify. What I'm going to get is, and I'm going to reorder these. I hope you see that's just 1. Okay, and I'm going to rewrite this bottom and simplify the top as well. So simplify. I'm going to get cosecant of x plus, and then I'm going to write sine of x plus, and then add these together, 2 all over. I'm going to get my cosecant of x plus sine of x plus 1 plus 1. So I'm going to get the same exact thing on the bottom. And then there you can go ahead and say simplify again. And we get 1. We just matched, and I kind of hit it over with all my scribble, but there I matched the other side. Alright, so that's it.